Okay, so sorry if you're watching this second video about superposition. We want to solve the circuit using superposition. In the first video, I labeled these four independent supplies, A, B, C, and D. I don't know, I hope, yeah, I think you can see. This is the 8-volt power supply, the minus 15 milliamps, the 11 volts power supply, and the 10 milliamp power supply. Now I copy these 4 times so that I don't spend, you know, a long time just redrawing the circuit. So here's what we're gonna do. Just the A is going to be my first circuit, and I need to turn off the B, C, and D. To turn off a current supply, I open it. So I made a white rectangle here. It's going to be very obvious that I am turning it off, or I am trying to make an open from the node on top to the bottom. So if you were drawing, you just not draw that and not draw any connection. However, to turn off a voltage supply, we have to make a short between the two nodes. So I'm going to attempt to first undraw the C power supply, but then I want to make a short between the left side and the bottom and the right side. So let me get this to the front. And so this is how you draw the circuit there, shorting the two sides. I'm not sure how good that is, but this is much easier than me redrawing this whole circuit. So, and then I'm going to turn off this other power supply. So I hope you see that the 3 kilo ohms is still connected to the minus 50. Oh no. Oh. Okay. Obviously this is not working. There. Now it's working. So actually this 3 kilo ohms is now open. So you do not need to draw it. The 7 kilo ohms is still connected to the 2 kilo ohms. So everything else here is still connected, and these resistors are also connected one to the other. This is going to be a delta connection. It's very hard to turn this into a Y connection, even though it would be possibly easier to handle later. But for now, this circuit you could solve as nodal analysis or mesh analysis. Let me turn the computer to me here. Now we're going to do the same thing with the next 3 circuits. If you can stop this video and try to see how the circuit will look like without the other power supplies, that would help. So this, let me say one more thing about solving this first circuit. Because we're asking what is V7, you would say V7 due to A is whatever. Let's say we find the V7 is, this one is what, 8 volts. Let's say we find the V7 is 2 volts. So we'd say V7 due to A is 2 volts. And now we're going to find V7 due to B. For that, let me copy and paste here. I'm going to turn off this guy. And I'm going to turn off D. And I'm going to turn off C. Except that C and A are voltage supplies, so they need to be shorted. D is a current supply, so I can leave it open. Let me short those 2 other ones here. So I want to short this to here, and I want to short this right side to the left side there. I realize it's not very good. I wish I could just draw on it, but actually maybe I can, but then I wouldn't be drawing very well. I hope you see how it looks like. This circuit is only due to B, and B is in series with the 3 kilo ohms, which I really don't like, but there is a minus 15 milliamps going here through the 3 kilo ohms. And now let's do the third one. So I'm going to turn off A, B, and D, and I'm going to leave only C, except that A should be shorted. Oh, do I know how to go up here? There. So there is no 5 volts there. Hopefully this makes sense, how to then draw the circuit. And now the last one is only according to D. So I'm going to turn off A, B, and C. But A and C are voltage supplies, so I need to short them. So let's do that. So A should be this guy. Okay, hopefully, even though this is not perfect, yeah. So now you see what happens is, let me insert a text box here. So now V7, oopsie, V7 will be the V7 due to A plus V7 due to B plus V7 due to C plus V7 due to D. And often my students still want me to do a numeric example, and of course I have no idea what these V7s will be, so you have to solve each one of these. But let's say the first one was 2 volts, the second one was 1 volt, the third one was minus 4 volts, and the fourth, the D will also be negative, right? Because it's going to go down, let's say, plus minus 1 volt. So then you would add up 2 plus 1 is 3, minus 4 minus 1, minus 1 is minus 2 volts. So in the end, I'm totally making this up. V7 would be minus 2 volts, and you had to solve these 4 simpler circuits than the main circuit. So I hope this helps with superposition. The concept is very simple. Yeah, you know, it's just adding the output of the circuit for each one of the independent power supplies. But I feel like drawing, if it's a very complicated circuit, it takes a long time. I hope this helps.